Hello, everyone. How's everyone doing? Um, if you can't hear me, if you can't see me, if the sound comes out wrong, please let me know in the comments section. I'm going to do whatever I can to get it fixed if there is a problem. I always keep having some of these technical problems. I don't know why. It's a new camera, but somehow, when I talk, there's a vibration in my voice located by the camera. And I have no idea why it does that, okay? So let me know if there's any problem with the voice especially. I don't think there's a problem, at least for now, with the video, but I've had problems with the video as well. So, just notify me in the comments section. Um, as most of you know, Hans, my dear son and partner here, he's in Argentina still. He's going to be there, I guess, a couple months. So he might participate now and then, okay? Come in from the other side of the world and join us, ask questions or whatever. And as you all know, I was recently in couple days ago, I was in in an interview, and in that interview by a man from Quebec, Canadian, I was interviewed on the issue of the rope model, specifically two issues. One of them is the what is physics? Do we need physical interpretations, which is what I covered in Buenos Aires. And the other one was the rope model itself. And, you can say it went well, you can say it went bad. The important thing was to get people to be aware that there's a competing theory, that there's a competing proposal, specifically a competing hypothesis. And as we all know what a hypothesis is, it's what we propose as a mediator for light, or also gravity, also magnetism, electricity, the whole works. And so, when you have a new proposal, obviously that tends to wake people up. People say, what do you mean a new proposal? We have something new out there? Because every day people hear just the same thing over and over again. They hear black holes, Big Bang, dark matter, particles that travel backwards in time, time travel, that your twin is much older than you, and that kind of thing. And so when you say, look, I've got something different to offer, people say, what can you possibly have that's different than all that? So people are not aware that there is a new theory, a new proposal out there, and just to get it out there is a monster. It's unbelievable how difficult it is. Anyways, I had this interview. It was divided in two. One was what is physics, the other one the rope hypothesis. And today I'd like to talk a little bit about the first part because we can't seem to understand yet that what physics is about. What is physics about? And that was essentially what I was trying to get through. It was not easy. And I want you to know that JFG, this fellow, Jean-Francois Garipi, I think that's how you pronounce his name. I'm not sure. Everybody just calls him JFG, and I'm comfortable with that. He's got a podcast, right, out of Canada, and well, he told me in advance before we went live. He said, I'm going to play devil's advocate, and I said, yeah, good. Please be my guest. Beat me up as best as you can, because that's the point. The point is to put you on the spot and to try to get you to answer the hard questions. And I like that. That's good. I accept the challenge, so to speak, and there's a lot of material to cover, and there are also many assumptions that people have based on their education, based on their biases, on, what they studied or what they were taught in high school and college. So there's a lot of barriers to break down, and so it's not an easy conversation when you have people with totally different views on a subject. So keep that in mind. That's the context. That's what's out there. Anyways, I think JFG represented quite well the party line, whether he was doing devil's advocacy or actually presenting his own point of view. That's, in my opinion, in a way irrelevant, because we got to look at the issues, not what people believe in. And so the fact that he represented the party line in many ways, in many of his questions, I think was quite well. It was quite interesting. And I think it's exactly what we need. We need to compare the rope model against what quantum has, against what relativity has. Okay, so the key question, as I understand it at least, that was what was important to me. The key question was, do we need objects to do physics? Can we do physics without an object? And this goes to my what I call the golden principle of physics. I think it's a non-negotiable principle. Okay, that's where physics starts. Do we need an object to do physics? And the way I look at it, right? Just this is my opinion. Religious people will say that you don't, because they have no problem doing physics with spirits. They just want to get away with it. They say, look, all I need is to have some kind of description of what's going on, and that's sufficient for most people. They say, I can live without objects. In fact, that is more or less the position, or you could say almost a definition of what religion is, that you have things done by miracles. So you don't really need an object. God sends His Spirit, whatever that Spirit is, some force, some energy, and because of that, the Spirit, the energy, creates some effects, does something, and you don't know how He did it. You call it a miracle because you've never seen that on earth. You've never seen something like that done in real life, and so you just call it a miracle and leave it at that and say, thank God that God's watching over us and that He sends His spirits to do His magic. Fine. And those are the people who are going to say that you do not need an object to do physics. That's where it starts. And that's more or less the position that JFG took yesterday, 2 days ago. He took a position, and in fact, I'll read what he said because those were the critical points, and these are things that we have to keep in mind. And he said the following. He said, think of things like objects. It does bring some assumptions. To talk of objects, you are already talking of a space in which these objects are embedded. And so not everything in physics has to be objects, because objects are bound to be a kind of subset of what the universe is about. If we are to talk about these objects producing forces on each other, then we are really modeling how these objects interact with each other in a space with properties of speed, of Newtonian mechanics, etc. If we are to care about how these objects spread across the universe during the Big Bang, from the Big Bang to here, then we need relativity, and we need these equations that bend space-time. It is clear that the reality that we invoke in physics must invoke something else than an object, because physics is about describing the universe in which these objects can exist as part of a subset of what can exist. So here we have everything that exists, right? And concepts, I guess, or non-objects are a subset of what can exist. And again, that has to do with the word exist. I'm not going to get into that. I'd like to talk more about objects. The point here is he's saying that, well, you don't really need objects. You can do physics without some objects, because objects are just a subset of what exists in the universe. In other words, he's kind of saying that, we don't really need an object because there's more than objects in there. We have concepts out there as well, like floating around, I guess, or that are of concern to a physicist. because we're talking again about physics. So it's like saying, we don't really need an object because, physicists can deal with concepts, and that's a subset of everything that's out there in the universe. Okay, so I insisted and I said, well, no, I mean, if we remove all the matter from the universe, can we do physics without objects? And so he clarified a little more. He said the following, and this leads us to what we need to understand here in this discussion. In principle, you could have a model that explains objects without referring to objects as anything other than a secondary effect of that equation. Notice he brings the word equation in there. And I think that's essentially what modern physics theories are. And there he is right. He is totally right there. Math and the idea of objects is just a manifestation. If you look at quantum Darwinism, for example, math and the classical physics properties are an emergent property of an underlying system. Okay? So yes, I would say that we can have physics that doesn't specifically mention objects, but where objects and visible atoms emerge as a consequence of the properties that we give to lower levels. I guess we could call them lower level objects. They are not objects in the sense of they could be seen in the universe, but they are objects of the encompassing theory. So when quantum Darwinism says, all right, there's a competing set of information systems within the quantum universe, and as a consequence of this competing set of entities, there is an atom emerging here or a particle emerging there. Or when quantum field theory tells you that this time and explains it in terms of the activation of certain fields or certain interaction between certain fields, I believe that those theories are objectless, if you will, but that creates objects in the end. And again, he's referring to the description of mathematical description, typically through an equation of something that happens, or you put it in the form of an equation, and the equation can dispense with the object. In fact, I've got a very good example. I want you to think about this. You ask the Eskimo, and you say, why did the sled end up in the water, in the lake? And so he tells you, he says, well, my husky pulled the sled and he fell into the water and just dragged the sled with him. And you say, what? E.T. comes over and says, what's a husky? He said, what's the type of dog? And E.T. insists, says, what's a dog? And the Eskimo said, well, a dog is a four-legged animal, blah, blah, blah. Better yet, he points to one of his dogs and says, that's a husky. That's the type of dog I'm talking about. Or he shows him a picture and says, this is a husky. So we've identified the object. What do the mathematicians do? They do something a little differently. They say, look, what pulled the sled into the water was mass and force. What you have is not a dog. You replace the dog with 30 pounds because that's what mass is for a mathematician. He doesn't see a dog, he sees 30 pounds. And worse, that 30 pounds is represented by a point. So he puts a point and he labels it 30 pounds, and he just says the dog, the point, the 30 pounds pulled on the sled. That's how he describes this whole thing of what happened. And is that a cause? Can we say that a point weighing 30 pounds pulled on a sled? Does that make any sense? Is that an explanation of what happened? No, the reason he puts the point and he labels it with 30 pounds or tells you that it weighs 30 pounds is because that's what he can put in an equation. And what is an equation? It's a description. Okay, so let's get this right. We're replacing the dog, right, with 30 pounds. And we pictorially represent that with a point. So we put a point, we label it 30 pounds, and now we can use the 30 pounds in an equation. And we can explain, why do we need that? Well, we need it because we need to show what the force was. You know, force equals mass times acceleration. Okay, what's the force? The force is just what was needed to get the sled into the water. And for this, he needs the mass. He needs to know how fast it went, so that's the acceleration part. But the point here is he's not explaining the mechanism of how the sled ended up in the water. He's describing, because he's trying to quantify the whole situation. He's saying, look, you need so much mass and so much acceleration to create such a force, meaning to pull the sled into the water. So he's giving you a mathematical description when what we're asking, how did the sled end up in the water? That's why he absolutely needs to replace the dog with a 30 pounds. And this is what they're doing. That's what they're doing across the board. They're doing that not only in this case, which is an obvious case, but they're doing that across the board. They're doing it with light. Do they tell you what light is? No, because what are they going to, let's assume light is a rope, as I'm suggesting. Are they going to put rope into an equation? No. What they're going to put in an equation is little c. They're going to put 300,000 kilometers per second, a constant. Or they'll just put the little c. And that's what they need. They don't even need the particles. They don't need the wave. They don't need these objects with which they represent light, and they don't believe in them anyway. They could care less, because what they're interested in is in the mathematical or quantitative relations on both sides of the equal sign. That's what they need. So they can't put a rope in there. And likewise, you know, if you have a magnet attracting another, they might go and talk about Gauss. If they talk about an electron, they might talk about charge. You know, what is it? 1.6 times 10 to the minus 19th coulombs, or so on. You know, they're going to put a value, because that's what they deal. That's their bread and butter. They deal with equations. They deal with constants, variables, you know, numbers. That's what they deal with. And so they can't put a little ball, assuming the electron is a little bead. They can't put a bead in there. What are they going to put a bead in the equation? And this is where the problem is. The problem is that because they don't deal with objects, they've never defined objects. They never will define an object, and the word object, right? And so the question is whether we need objects to do physics. Obviously, we don't need them to do math, which is what they do. Do we need objects to do physics? And for this, we have to define what physics is. And of course, if like JFG suggested, whether it was his own opinion or whether he was just representing the establishment or playing devil's advocate, he's saying that physics essentially needs equations. You need to quantify things. You need to establish relations. And if that's the case, yeah, then physics is math, math is physics, and everything is in perfect order. But if physics is something else, if physics deals with trying to explain how a magnet, by what mechanism a magnet attracts another, or how a pen fell to the floor instead of to the ceiling, you know, what caused it to fall to the floor, then we can't use the math. Then we need to replace all that math with objects. And for that, the first step is to define what an object is. And that's why no one has ever defined the word object, because they never needed it. You don't need it for math. You don't need to deal with the object themselves, which is what JFG is saying here. We do not need objects to do math, but we need objects to do physics. And so the question is math the same thing as physics? Is physics the same thing as math? And what they've done, the mathematicians, since the days of Newton, at least, since the scientific revolution of the 17th century, is move ever more into the realm of math, because they could not explain phenomena. They could not explain what electricity is. They could not explain what light is, or what the magnetism is, what gravity is. All these unseen, all these invisible entities or phenomena, you know, they just couldn't explain it, because in order to do so, they would have to try to make the invisible visible. They would have to show us what physical object, invisible object, Mother Nature's using to cause such effects. And since they just kept doing math because they thought they would reach an understanding through math, and because they were also developing technology rather than trying to do science, trying to get explanations, they drifted little by little, ever more so, into the mathematical world. And that's how we arrive at Mr. Max Born, who said, physics, quotations, physics has become more abstract. What does he mean? What did he mean by that? He meant that we got farther and farther away from physics. We are doing abstractions, not physics. And that's why we don't have an answer for simple questions like, how does a magnet attract another? Or what causes gravity? And the answer that these people give you today to the layman who asks such questions is, we're still investigating. Or they'll say, we'll never figure it out because of several things. First, Mother Nature is too complex, or they'll say that your mind, the human mind, does not have the ability to understand how this universe really works. The universe works differently than our minds, and we can only try to comprehend it in our terms. And the way we comprehend it in our terms is through math, because math is objective. We created this language called mathematics, and from there we can understand it. Quotation. Because again, they cannot explain, something as simple as gravity or magnetism. So they cannot explain the mechanism. They cannot explain the cause, but they can describe it, and they call that description science, or they call that description physics. And I always quote Mr. Donald Simonek. He's an emeritus professor at Lock Haven University, Pennsylvania, and he says, unambiguously, he says, science does not explain, science describes. Why did he say that? He says that because mathematics describes. Mathematics does not explain, so they equated math with science. And so when you ask someone, what is an object? They say, where did that question come from? Why do we need an object? And yes, you don't need an object in math, you need it in physics. You need it if you want to explain how a magnet attracts another, because you have to identify that invisible entity that forms what we call the magnetic field. You have to know what is twirling around there. There's, like James Maxwell said, there's matter in motion. That's what a field is. Matter in motion. Some exotic type of matter. It's not your everyday kind of matter. It's not made of atoms. There's something moving in there. And he says, I don't know what it is. That's what Maxwell said. He just kept doing math. And today we say the same thing. The mathematicians out there, they'll tell you the same thing. There's something in there, obviously, or someone might even say there's nothing. But if those who say that there's something in there, they've failed to identify what that something is. And they're not interested in identifying, again, because they do math. And that's what we're at with JFG here. Let's see if I put it back up there again, so we can see what he's saying. He's saying, in principle, you could have a model that explains objects without referring to objects as anything other than a secondary effect of that equation. So he's saying we don't need the object. The object is irrelevant, because what we're trying to figure out here is understanding, and not, I can't even say it's understanding, describing what happened. So we're describing what happened. We do that with an equation, and for that you don't need an object. You don't need the dog to pull on the sled. You can say mass pulls on the sled, and you're fine with that as long as you say the sled fell into the water because there was a force that pulled on it. That force was caused by a mass that was there, right? In this case, the dog. You replace the dog with a point particle. You may weigh 30 pounds, and you can say, see, I can explain or describe really how the sled ended up in the water. And so JFG continues. So yes, I would say that we can have a physics that doesn't specifically mention objects, but where objects and visible atoms emerge as a consequence of the properties that we give to lower levels. And he calls those lower levels, he said, we could call them objects. They are not objects in the sense of them being able to be seen in the universe, but they are objects of the encompassing theory. In other words, we're talking about mathematical objects here. That's what he's referring to. He's saying that, if you have an equation and that equation is describing something about objects, but we don't need the object itself because we're interested not in the object but in the equation. And yes, that's again replacing the dog with mass. And you're saying, look, we're interested in how mass behaves and not what the dog did. That's what's happening here. And that's where we stand today. We stand today in this notion that we can just get away with descriptions, and that's the serious problem. It's a serious problem because people have been educated to think in those terms. You go to high school, you go to college, that's what they teach you. They teach you, forget about the causes, forget about the mechanism. That's philosophy. So don't bring it into our world. What we're interested in is learn the equation because I'm going to test you on Friday, and you better know how to calculate the force. And you're saying, I just kind of wanted to know, what the mechanism was, how the magician did the trick, not the fact that he cut the lady in half and he did it with 10 strokes of the saw, and that it took him 10 seconds. I don't care about any of that, but that's what mathematicians care about. They describe everything in terms of these values, of these units that they've created, and that's their world. And unfortunately, these people are in charge of publishing. They have censorship power, and that's the world we live in. So I just want you to understand the context of what we're up against. Now, if there's any consolation, I was telling our dear Monkey, to check in today. I don't know if he has, but anyways, I'm going to say the following. There was a gentleman who made the connection with JFG and said, look, he contacted me, I think it was in October. He says, would you like to be on this show, on this podcast, and talk about the rope model? And turns out he was also wanting to talk about the Neanderthals, about extinction, other things. We talked a little bit about that with JFG before the show, and he liked that idea as well. In other words, it was challenging for him because he's got a different idea about it. It turns out, when this guy contacted me in October, he said, would you like to be on the show? And I said, look, I got to go to Argentina. We've got a presentation, conference over there. And when I get back, sure, no problem. So he set it up for the 7th of December, and it did materialize. We did have it. And after the show, it turns out this same fella contacted me. He said, he thought we did great. I did great, or both JFG and I did great, because he was part of the show, obviously, as an interviewer. And he says, the show was good. He liked it. And what he wants to do is he wants to do a follow-up. And the follow-up consists in, he wants to bring a physicist. He's putting out the word to see if he can get a physicist to debate. And so we would pit not only, again, I think we would have the same two subjects. We would have not only the rope against quantum and general relativity, against mathematical physics in general, but I'm sure we would talk about the foundations of physics. What is physics about? And I don't know if it's going to materialize. I don't know if any physicists will want to come, mathematical physicists, will want to come and debate something with which he may not be so familiar with, or where we're going to deal with a subject that he says, well, that's not physics. He's going to try to brush it aside. That's what's going to happen for sure, if it ever happens, if the show ever goes live. But if we could get there, it would be an interesting debate. It would be an interesting exchange. You would see a religion that perhaps is dying against a new religion that's emerging. So stay tuned. We'll find out if this materializes. If there is a debate, that could be quite interesting. We're going to be clashing heads together, with this guy, and it's not going to be pretty. Okay, I guarantee you that in advance. It's not going to be very pretty. But the point is, I wish that would happen. That we get someone in there and we get to debate them and we get them to answer some of the tough questions. Is physics about objects? Is there a difference between math and phys? And if he concedes that we do need objects to do experiments, for example, I mean, obviously you need if experimentation is part of science and physics is a part of science and you need experiments in physics, well, apparently you need an object to carry out the experiment. So as a minimum, you say, well, maybe, as JFG here said, maybe the universe has more things than just objects. Okay, let's just concede for the sake of argument. Do we ever need an object in physics? And if the answer is yes, then fine. That means that now you have not only the opportunity, but you have the duty, the obligation to define what an object is. And that's where I want to see them squirm. I'm sure that they're going to have a tough time defining what an object is. So that's where we stand. Hopefully this follow-up, this debate happens. And if and when it does, it's going to be very interesting. And of course, I'm going to publish something along those lines for the Rational Scientific Method on Facebook so that everybody can come in and join and have a little fun. Okay, if there are no questions, let's see if there are any. Let me check that real quick. No questions. I'll give you 1 minute here to come up with any questions you might have, and otherwise I'll just adjourn for today and continue tomorrow. Anyways, to summarize, the ANS is in South America still. It's going to be there for a couple months. I had an interview with JFG, French guy. Really, he's a Canadian guy, but he speaks French more fluently than English. But I like his accent. I absolutely love his accent. And I think it went well because despite that, he either played devil's advocate or just presented his own personal opinion, irrelevant. Totally irrelevant in either case. He did present the establishment's questions, and I think I answered them pretty straightforward. I kept insisting on the fact that physics does require an object, and I was able to present the rote model of light, just very loosely, in other words, just like an introduction. And he liked that, by the way. He said he really enjoyed the new model because he said, well, it does give some explanations to some things, and if it's worth considering. And then the punchline is that maybe, just maybe, we might get a physicist online to debate me, and that really would be interesting. So let's hope for the best and see if it happens. Okay. So stay tuned. I'm going to put something on Facebook if it ever happens. Okay. So we'll see you on Wednesday. See you then. Bye bye.